Hello everyone, welcome to this video. In this video, we'll be looking at another question from JAM Mathematical Statistics 2021 examination. Right, this is a 1 mark question and this is a MCQ type of question. So here in this question, they are saying to you that if M is given to be a 3 cross 3 real matrix and these 3 they are given to be the eigenvectors of the given matrix, right, M corresponding to 3 distinct eigenvalues, right, this is important, where alpha is a real number. Here this number alpha, that is some real number, right, then which of the following is not a possible value of alpha? So we cannot choose alpha as which of the following, right, in order to fulfill the condition that these 3 vectors, they are the eigenvectors corresponding to 3 distinct eigenvalues. So let's proceed on to the solution here in this case. So this is a very simple question, right? If you know a result which is for eigenvectors and eigenvalues, right? So let's first of all rename these vectors. So let's call the first eigenvector as x1 with entries 1, 2, 3. Let's call x2 as the second eigenvector with entries 1, 1, 1, and let's call the third one is x3 with entries 0, minus 1 and alpha. Let these 3 x1, x2, x3 be 3 eigenvectors, right? Let them be the eigenvectors of M. So this is known to us already, corresponding to 3 distinct eigenvalues. So in this case, we are to check what could not be alpha, right, or what could be alpha. So in this case, if you know this result that eigenvectors corresponding to different eigenvalues are linearly independent. They are linearly independent. If that is so, we are given 3 eigenvectors which correspond to different eigenvalues. So in this case, so that means all 3 of them, that means x1, x2 and x3 should be linearly independent, right? Why? Because they correspond to 3 distinct eigenvalues of M. If that is so, we are to see if you substitute alpha as 0 or 1 or minus 2 or 2, then could they be written in linear combination of each other or not? So here in this case, I am taking this option C, right? So if I take alpha to be minus 2 in this case, in that case, what would be your x3? Your x3 was 0, 1 and alpha. 0, minus 1 and alpha, right? So in place of alpha, now I wanted to write minus 2. So if this is your x3, can you write this as some linear combination of x1 and x2? Yes. How? If you write x2 minus x1, what would it be? It would be 1, 1, 1, that is x2, minus x1, that is 1, 2 and 3. So if you subtract them, what would you obtain? You would obtain 0, minus 1 and minus 2. So that means you have written x3 as x2 minus x1, which is the linear combination of x2 and x1. This is the linear combination of x1 and x2. So that means, so this shows x1, x2, x3 are linearly dependent in this case. So that means we are moving and solving this question by the method of contradiction. So we are looking for the odd one out. So we found one combination in which we have a linearly dependent vectors x1, x2 and x3. For what value? For the value alpha is equal to -2. If that is so, this shows that this means alpha is equal to -2 cannot be the possible value of alpha, and this is what was required to solve this question. Possible value of alpha, right? So we have option C as the correct option. So I hope you understood this question well. That is it for this video. Thank you for watching.